Okay, we started with these. We did the first three. Brianna, you guys might want to be paying attention that we're in here. We did the first three in class together. We said these come from the same applications that you did with your exponential curves. We had two packets. One that had the money on it, we did first. I called it part two, we did it first. And the other would have like the bacteria doubling and half-life. That was the second part of it. We did them graphically. So for this one, you would have had an exponential curve and where they cross. Now instead, we're going to solve them with logs. And when we use an exponent, the only thing to get the exponent down is a log. What you have to remember is this. The exponent only belongs to that factor. It doesn't belong to this one. We said two choices. If you could divide evenly by 1,500, then you can get rid of it and make it one term, one term. If not, once you take the log of both sides, and this is a product, this is being multiplied, you have to turn those into adds. Then, now, you can bring your 12t down in front of that factor. Yes, we're going to take this log and bring this over here to solve for t. It's if you had an equation that looked like this. You have to get x by itself, right? So you would say minus 2, minus 2. Same thing. We got to minus this piece to isolate the t. So once we do that, this is the factor we want to solve for. We want to divide both sides by the other two factors. And I also pointed out, be careful. You have to have this piece in parentheses. You have to have this piece in parentheses. And your calculator also gives you another parentheses when you do the log word. So you've got a lot of parentheses going on. But if your parentheses aren't by your groupings, you're not going to get the right answer. So we did this, and this has to come out the same way when we solved it graphically. Now on your test tomorrow, it's only the log part. So I don't want the graphs on this, I just want the log ones on this. We did this. We also did this one. Here was one of yours that you had compounded continuously. This was a PERT. When you use base E, and you go to take the log of both sides, you have to take the ln of both sides, the natural log. We also said you can use the ln at any time, but you must use it with base E. So doubling 2 to 1, 200 to 100, divide by the 100, it becomes a 2 to 1 ratio. Do I need the 1? No, I just put it there so you can see the double. When we bring the ln down here, and we bring this guy down, this is a property, ln e, they're inverses of each other, they cancel out. Divide by 0.06, and we rounded to 3 decimals. Again, we did this graphically. We said this was a exponential curve. We looked to see when it was with 2, and we found it in your packets with your exponents. It's the same exact problem. What the heck is going on out here? All right. Any questions on those? Especially you guys. We did that when you guys were here Friday, but you guys that weren't here, are you seeing what we did? We took the packets that you did already, and we redid them using logs. We did them graphically with exponents. We did them algebraically with logs. Okay. We did this one too. This was one of your AB to the X guys. This was the second part of the things we did. This is where you're going to put your rate in. We did this algebraically, and we set this up, and then we said, let's solve it using logs. Now, if you can divide this through, do it. If not, then set logs on both sides. I used ln to show you that logs and ln's are interchangeable. This is a product. use your rule for products. This is why you learned your rules. Isolate your variable. So subtract that from both sides. Remember, you cannot subtract 50,000 minus 123,000. You have to say ln 50,000 minus ln 123,000. Make sure this is in parentheses, or it's going to do the divide first. Divide by your ln, and you should come out with your answer. Go back in and check it. It's an exponent. So go back in, put it in with an exponent, work the problem out, and see if that's what happens. You're decreasing. This you can automatically do. That's not irrational. That's fine. Good? Right, that we did on Friday also. Okay. Number 7. This was one that we did the first day. We compounded quarterly. Even though I leave this, guys, and I don't put this in my calculator, if you put it in your calculator, go more than 3 decimals. Like, see this piece right here that I leave like that? If you put that part in your calculator, go more than the 3 decimals that you're supposed to round. And the same thing when you divide out by something. Just round it to more than 3 decimals. Go 4 or 5, and then you know your rounding is going to be more accurate at the end. You really shouldn't round till the end. It just leaves you with a lot more parentheses to have to go through. You don't need a parentheses inside that one, because it will do the divide and then it will do the add. So you are okay with that one. So you got log 2 over this guy. We found the formulas for these. We did the graphs, and now I just had you solve algebraically. Questions? No? Everybody got these answers? And it was nice because you could check them with what you already had. Okay, here was your bacteria. We did this on the second day. Now, again, be careful. This is your rate. This is where you double. That's a double. This is your time, but the time has a cycle to it. It has a cycle every 3 hours. So we put it in every 3. Now, determine when it will be 100,000. This is where we did your graph. We put the y1, we put the y2. Do it algebraically. This one, look, this divides very nicely. So if you divide this out, you're just left with this one piece. It makes it a lot easier than having to separate it into an add. Can you still take the log of both sides and separate it into it and add? Absolutely. So you bring this down in front. Now, my advice is get rid of the fraction. Multiply by 3. Like when you multiply this by 3, this comes out. You just have to multiply this side by 3. If you wanted to, you could technically do this. This is the same as 1/3 x ln 2. You could divide by 1/3 ln 2, both sides. Just watch your fraction. You can use either one for anything, but you must use ln for e. So you can use ln all the time. Remember, your natural log is like your exponent. The exponent for your base e came between 2 and 3. Your natural log falls the same way, so it behaves like a regular log does. So you can use ln all the time. In fact, I repeat this all the time, I know. In college books, most of them always use ln. Just because they are interchangeable, they just figure just use the one ln. But you have to use ln for e. That's its base, its natural base. Okay, so if you wanted to do it this way, you could, and not multiply it by 3. Just be careful of your fraction. I'd make sure you definitely have parentheses here when you divide. I just get rid of the fraction. Make life easier. Alright, here's your rabbits. Now, if you put x over 12 at the end, just divide your answer by 12. If you went every month and you went based on a year. You could use just the x and you will come out with your months automatically. So the other way, we just had to divide it by 12 if you did x over 12. We found this algebraically, and then to use your logs, this divides nicely. Look how nice that is. This is a nice little problem in here. You can use log just as easily. Log 500 equals log 2 of x. Bring down the x. And divide both sides by log 2. It comes out the same answer. I tend to just interchange them so that you can see they'll be interchangeable. Okay. And is this the last one? The last one had a half-life. Here was your half-life. And it had a cycle. So we said a half-life is decreasing. When we did these exponentially, we had a decreasing curve. We wanted to know when it would be less than 1. So we set it equal to 1. We did your y1, your y2, and we crossed them. And then we just said it had to be greater than this. It had to just be a little bit more than that to be less than 1 because it was decreasing. Now, when you do this, this is really not divisible at all. So set this up, use your log rule, use the fact that it's a product. That's what most kids miss. I'll tell you right now, a lot of kids end up bringing this down in front of here. Don't do that. It belongs to the 1/2 only. It does not belong to the 6.58. So you have to separate them. If you wanted to divide 1 by 6.58, just make sure you go out like 4 decimal places. Don't cut yourself short on the decimals. To get rid of the 14, I multiplied every term by 14. 14, 14, 14, every term. And that will take this guy out. Oh, bless you. You still have to multiply this by 14 and that by 14. Every term. Be careful again of your parentheses. Okay. When I give you the application on the test, I'll give you the formula, and you just have to solve it with a log instead of a graph. You can solve it with a graph to check it, but I'm going to need your log results, your log calculations. Questions? Okay.